Hi there, welcome to this video. If you're just about to start year 13 maths, then this is the video for you. We're going to go through an end of year 12 assessment, a refresh of all the content from year 12, looking at some pure stats and mechanics questions, getting you ready for year 13. So a good idea would be to pause the video, look at the question and see how you would answer, and then watch my solution. And remember, I'll include chapters in the description, so if you wanted to just go to a particular question, you can just hit the timestamps in the description. So question 1 starts off fairly straightforward. For part A, we're just asked to differentiate. So dy by dx, we need to power down 3x squared. That power there is 3 over 2. So when you take that down and times it by 10, it'll be plus 15x. Take 1 off the power will be a half plus k. Then in part B, we're told that at the minimum point P, x is 4, and at the minimum point, dy by dx is equal to 0. So when x is equal to 4, dy by dx is equal to 0. So we've just substitute 4 into the expression we've got. So that's 3 times 4 squared, which is 16, plus 15 times the square root of 4, which is 2, plus k must equal 0. So 48 plus 30 plus k is 0 tells us that k is minus 78. Now in part C, we've got an area, but the area is under the x-axis. So whenever we're going to integrate, if you integrate between the limits 0 and 4 of the curve, you're going to get the area trapped by the curve and the x-axis, which will be this area. Now, what we need to do is find the area of this whole rectangle and then take that away. So to find the area of the rectangle, we need to find this value here. So this value at n is when x is equal to 4 into the curve. So when x is equal to 4, y is equal to, now 4 cubed plus 10 times 4 to the 3 over 2, and then subbing in the k being minus 78, times that by 4, that comes out to be 168. So a minus 168. So what we need to do is ignore the fact that it's minus and just do 168 times 4, which comes to 672, which is the area of the whole rectangle. And then we're going to integrate the curve between 0 and 4. And because that area there between the curve and the x-axis is underneath, the answer we're going to get is negative. So we're just going to ignore the fact that it's negative, because that just means it's underneath, and then take it away from the 672. So integrating x to the 4 over 4 plus 10, x, add 1 on, will be 5 over 2. Now when you divide by 5 over 2, it is the same as timesing by 2/5, and then minus 78 squared over 2. Between 0 and 4, now putting your limits in, 4 to the 4 and divided by 4 is going to be 64. 2 times 10 is going to be 20 divided by 5, which is 4, times square root of 4 is 2, and 2 to the 5 is 32, and then minus 78 over 2, which is 39, times 4 squared, which is 16. So that's the top limit minus the bottom limit, which when you put 0 in as x, because each term's got x, is going to be 0. Now that comes out to be minus 432. So that's that area there. The minus just telling us that it's below the x-axis. So all we need to do is do our 672, take away the 432, and that comes out to give us an area of 240. Now you can do it other ways. You can do top curve minus bottom curve, but because this area is all underneath, what I mean by top curve would be this line here, which is the line y is equal to minus 168, and then take away the top curve, which is the one underneath, which would give you that area. You might get mixed up with your signs, so it's probably better to just get the area of the rectangle that we did here, the 672. You could, if you want to not get the 432 there, is just swap the limits round. So you're integrating between 4 and 0, and then it'll just turn everything the other way around. So you would get a positive answer there. But either way, whatever way you do, the answer is going to be 240. Next question is a log equation, and you need to use your log laws. Now, before we start, if you just a reminder that the way logs work is the answer to the log expression is the power. So if I wrote 4 cubed is 64, another way to write that in terms of logs is log to base 4 of 64 is equal to 3. So 4 cubed gives you the 64. They're just two ways of writing the same thing. So the other log laws that you need to know, if there's a number on the front, that needs to come up as a power. So let's start part A and do that. Log to base 4 of 2x plus 3 all squared is equal to 1, and then because these two logs are added, you can just put them as one log. Log to base 4 of x into 2x minus 1. Take that to the other side and it'll be a take away, and so you'll have two logs being take away, and then that will be a division. So log to base 4 of 2x plus 3 all squared all over the x into the 2x minus 1 is equal to 1. Then it's one log, all that algebra, and then the 1. So 4 to that power 1 is equal to all of that algebra, and 4 to the 1 is 4. So you can then write 2x plus 3 all squared over, and multiply this in, 2x squared minus x is equal to 4. Cross multiply and squaring this bracket out, you're going to get 4x squared plus 12x plus 9 is equal to 8x squared minus 4x. Taking everything to one side to get the quadratic term positive, you're going to get 0 is 4x squared minus 16x minus 9, which is what we want. Now you could, if you wanted, instead of doing all that, at this first line, you can express that 1 here as log to base 4 of 4. So on the right hand side there, you'd have log to base 4 of 4 plus log to base 4 of x into 2x minus 1, and because they're all added, that would be log to base 4 of 4x to x minus 1, and that would be equivalent to this right hand side. And then you could just lose the logs from both sides, and you'd still end up with the same thing, that 2x plus 3 all squared is equal to this 4x into 2x minus 1. So either way you want to do it. For part B, we're then asked to solve. So this expression is exactly the one we've been working with. So how are we going to solve? We're going to solve this quadratic. We're going to do that by factorizing. So it's 2x and 2x. We're going to need a 9 and a 1. We're going to go down 18 when these two times together, and then back up 2. It's equal to 0. So x is equal to minus a half, or x is equal to 9 over 2. Now x can't equal minus a half because we're taking the log of it, and we can't take the log of negatives. So to get the full marks, you need to rule out one of your solutions, and the answer is that x is equal to 9 over 2. Question 3, this is the modelling question. We've got this equation here modelling the value of a car after Lynn has bought it. So obviously she's bought it at this price here, and then it's come down. So what we can do to state the range of V, so this word state usually means you don't have to do that much work. What we just have to have a look at is when t is equal to 0, well, anything to the power 0 is going to be 1, so V will just be 18,000 plus the 4,000 plus the 1,000. So when she bought the car, it was 23,000. 1000. Now what we need to look at is when t gets big. So as t tends towards infinity. Now these graphs, when you've got anything to the minus, they're all going to come down, but they're never going to touch the t-axis or the x-axis. So this part of the equation, they're both going to tend towards 0, so you'll just be left with this part. So v tends towards 1000. It's never actually going to get there because these parts of the graph will still be above 0, but they'll be very, very small. So the range is just going to be between 1000 but not equal to it, but then it can be equal to the 23,000. Now part B, find the rate, another key word there, at which the value is decreasing when t is 10. So as soon as you see that word rate, that means you need to differentiate. So we need to do dv by dt. Now e is the one function that when you differentiate, it differentiates to itself. So e to the x differentiates to e to the x. E to the 3x, when you've got a coefficient in front, differentiates to 3e to the 3x by the chain rule. So because we've got these minus 0.2s and minus 0.1s, they need to come down. So you're going to have 18,000 times minus 0.2 e to the minus 0.2t plus 4,000, and then that minus 0.1 will come down e to the minus 0.1 t, and then the 1000 will just go out. So all we need to do is substitute in t is equal to 10 on our calculators into that. The rate dv by dt is minus 634. Now you don't actually need that minus. The fact that it's decreasing means it's negative, so you can just say the rate is decreasing at a rate of 634. Now for part C, calculate the exact value of t when v is 15,000. Now this is another keyword. Exact means we can't give it as an actual decimal. We've got to try and find a way of giving it as an exact value. So we need to set the 15,000 equal to our v, which is our 18,000 e to the minus 0.2t plus the 4,000 e to the minus 0.1t plus 1,000. Now what we can do, take that 1,000 to the other side and then divide by 1,000. You're going to get 14 is equal to 18. Now instead of having e to the minus just means it's going to be underneath e to the 0.2t plus 4, and then again this one is minus, so that's going to be really e to the 0.1t. Now what I'm going to do is times throughout by e to the 0.2t. So that's going to give me 14 e to the 0.2t. If I times here by e to the 0.2t, they'll cancel, so I'll just have 18. And then here I'll have times e to the 0.2t, and then using our rules of indices, you take them away. So 0.2t minus 0.1t will just be 0.1t. So this will be 4e to the 0.1t. And now what I'm going to do, instead of thinking of that as 0.2t, if you think of it as 14e to the 2/10 t is equal to 18 plus 4e to the 1/10 t. I've actually got a disguised quadratic because you can take that 2 out. This is 14e to the 1/10 t all squared is equal to 18 plus 4e to the 1/10 t. So what I can do is let y equal e to the 1/10 t. So what I'm going to have is 14y squared is equal to 18 plus 4y. Now I've got a quadratic. I'm going to take everything to one side. 14y squared minus 4y minus 18 is equal to 0. I need to factorize to solve it. So it's going to be 7y and 2y to give me the 14. I need a 9 and a 2. So here I'm going to make minus 18 here and plus 14, and that's going to give me the minus 4 in the middle. So here y is 9/7, or y is equal to minus 1. Now what was my y? My y was e to the 1/10 t. Now e to the 1/10 t can't be negative, so that rules that one out. So I've got e to the 1/10 t is equal to 9/7, and all I need to do is take ln's to both sides. So 1/10 of t is equal to the ln of 9/7, so t is equal to 10, the ln of 9/7, and that is your exact value of t. You don't need to put it as a decimal. This is another modelling question. We've got this tunnel and a lorry to see whether the lorry can fit through the tunnel. Now it's not just a case of finding the area of the lorry, you've got to take account of the dimensions. When it drives through, is there enough height for this lorry to pass through? So what we need to do is find an equation for the tunnel. Now we can see the tunnel is a parabola, it's a negative quadratic. So if we think of minus x squared has got this shape and it has moved 6 up, so we could have y is equal to minus x squared plus 6, but just in case it wasn't just minus x squared, there could be a coefficient in front of that. So what we need to do is find that a. So if we put some axes on here, we can see, because this is 8 and we're going to model it as a quadratic, this would be 4. So we can say that when x is equal to 4, y is equal to 0. So 0 is equal to 4 squared is 16, so that would be minus 16a plus 6. Take that to the other side, 16a is equal to 6. A is 6 over 16, which is 3/8. So the equation of the tunnel is y is equal to minus 3/8 x squared plus 6. Okay, now what we need to do is see whether the lorry will go through. Well, when the lorry goes through and it's like symmetrically in the middle, that point there would be that x is equal to 3. So we need to know what's the y coordinate of the tunnel when x is equal to 3. So if we say when x is equal to 3, y is going to be minus 3/8 times 3 squared, which is 9, plus 6, and that comes out to be 21 over 8, which is 2 5/8. So the actual height of the tunnel is 2 5/8, and the actual height that the lorry needs is only 2. So 2 5/8 is bigger than the 2, so yes, lorry can fit through. Question 5 is a proof question, and for both of these parts you need to use proof by exhaustion. So this expression, to show that it's not divisible by 4, we need to show it's not divisible by 4 by both even and odd. So when n is odd, so let n, to make sure it's odd, equal 2k, which would make it even, and then plus 1. So putting that into the expression, it's 2 of n squared, which is 2k plus 1 all squared, plus the 2k plus 1. So squaring that bracket, we've got 2, 4k squared plus 4k plus 1, plus another 2k plus 1, which is 8k squared plus 8k plus 2 plus 2k plus 1, which is 8k squared plus 10k plus 3. So if we try to take out 4, it would be 4, 2k squared plus 2k, which would give us 8k, and then we'd need another 2k plus a 3. So it's not divisible by 4 because we've still got this 2k plus 3 after we've taken a factor of 4 out. So that is not divisible by 4. So what about when n is even? So we need to let n equal, this time 2k would make sure it's even. So putting that into the expression, it'll be 2 times 2k all squared plus 2k, which is 2 times 4k squared, which is 8k squared plus 2k. This time we took 4 out, you'd have 2k squared plus 2k, and then again, because of this bit on the end, it's not divisible by 4. So by exhaustion, for both odds and evens, we've shown that both are not divisible by 4. So 2n squared plus n is not divisible by 4. Then for part B, this expression here, well, if you just think about the graphs, if we had e to the 3x, then e to the 4x would start off underneath and go above. So here, proved by exhaustion, we need to look at when x is negative and when x is positive. So when x is less than 0, e to the 4x is less than e to the 3x, and when x is above 0, e to the 4x is above e to the 3x. So it's sometimes true, but then the only point we've not looked at is here. So when x is equal to 0, e to the 4x equals e to the 3x. So it's only true for this bit here. So always true, sometimes true, never true. It's actually just sometimes true for when x is bigger than 0. Solving some trig equations, replacing the tan x for cos. So we've got 4 sine x over cos x sine x cos x plus 4 sine x over cos x, replacing the tan, cos x plus 1 is equal to 0. These coses will cancel, so we'll have 4 sine squared x plus 4 sine x plus 1 is equal to 0. And then factorising 2 sine x, 2 sine x, 1 and 1, plus and plus. So sine x is equal to minus a half. Now, if you know that sine 30 is a half, sine of minus 30, so sine to the minus 1 of minus a half is equal to minus 30. That's what your calculator or your knowledge of graphs, but we want an x in the range between 0 and 360. So either using the sine graph, so your calculator has given you that one there, where it's minus a half, and then you just need to use that principal angle and go 30 above 180 and 30 back from 360. So it's going to be 210 or 330 degrees. If you're using the cast diagram, the principal angle 30 would be positive in these two quadrants. You need to go in these two quadrants. So it's 180 plus 30 and 360 back 30. Both ways will give you those two answers. Onto the statistics section, and then this is all about sampling. So we've got a principal of a school. There's 3,200 in the school. We want to take a survey of 60 of them, and we want a simple random sample. So random we can only have when we've got a sampling frame, which is a list of all the students. But because we know we've got 3,200, we've got everybody in this population, so we can do a random sample. You wouldn't do names in a hat because this this is fairly big, but what you could do is allocate or give each student a number from 1 to 3,200. Use random number generator to get a 4-digit number. We would ignore any repeats or any outside of the range, because 4-digit number you'd get them bigger than 3,200, and then keep going till we have 60 pupils. So something like that is 4 marks. So we've got to say, 4 things. Next question is a Venn diagram question, and when you've got these values in the particular sections, that means the probability of the intersection of A and B is 0.1, probability of being neither in A or B is 0.32, probability of A just on its own is X and B on its own is Y. So part A, find an expression in terms of X for the probability of A. The probability of A is those two sections added together, everything that's in A, so that's going to be X plus 0.1. Find an expression in terms of X and Y for the union. The probability of A union B, will you just unite all those sections together? So that's going to be X plus Y plus 0.1. Now in part C, given that the probability of A is double the probability of B, find X and Y. Now we've got 2 values, so we're going to be doing some sort of simultaneous equations, either by elimination or substitution. So what do we know? Because we've got this 0.32 on the outside, if we do 1 minus 0.32, that gives us 0.68. So the sections that must add to 0.68 are the X plus Y plus 0.1 equals 0.68. So that tells us that X plus Y is 0.58. Now using the given fact in the question, the probability of A, which is X plus 0.1, is equal to twice the probability of B, which is 2 times Y plus 0.1. And then from this, if we say that Y is equal to 0.58 minus X and substitute that in here, we'll get X plus 0.1 is equal to 2. The 0.58 minus the X, which is standing for Y, plus 0.1. X plus 0.1 is equal to 2. The 0.58 plus the 0.1 is 0.68 minus X, and then multiplying that in, X plus 0.1 is equal to 1.36 minus 2X. Collect the X's on one side. 3X will equal 1.26, and if you divide by 3, X is going to be 0.42, and then if you use the fact that X plus Y equals 0.58, Y will have to equal 0.16. This next question is the binomial distribution and hypothesis testing. So for part A, we've got a head teacher claiming that 30% of the parents do not support the curriculum, and we've got a random sample of 20, and we're being asked what's the probability that A is equal to 5. So X is binomially distributed because you either support it or you don't. Our sample is 20 and it's 0.3, and we're just asked for the probability that X is equal to 5. So you need to go on your calculators and do binomial CD with X is equal to 5, N is 20 and P is 0.3, and if you do that on your calculator it comes out to be 0.1789 to 4 decimal places. In part B, we've then got a director of study, so a different teacher believing that the proportion who do not support the curriculum is greater than 30%. So the 30% is the default of what we have at the moment, but this teacher thinks that that is wrong. So given that out of the 28 do not support, we're doing a hypothesis test at the 5% level, and state your hypothesis as clearly. So we've got X being binomially distributed with 20 and P. So we're going to state our hypotheses. The null hypothesis is the current state of play, which we think is 0.3. That's what the head teacher is claiming. And then our alternative hypothesis, because of the wording of the question, this teacher believes it's greater, so that is going to be bigger than 0.3. We assume that H0 is true. So given that H0 was true, we would expect 30% of our sample of 20 to be supporting the curriculum, or not supporting the curriculum. So what is 30% of 20? That's going to be 6, and actually 8 do not support the curriculum. So it is higher, which is tending to agree with the Director of Studies, but what is the probability of X being that 8 or more? And on your calculators, you'd have to do 1 minus the probability that X is less than or equal to 7, and that turns out to be 1 minus 0.7723, which is equal to 0.2277. Now you compare that amount with the level of significance. So we're comparing 5% is going to be less than the 22.77%. So putting that decimal as a percentage so we can compare. So we were expecting 6, we got 8, which is not far away from that 6. And the probability, given that we're expecting 6 and getting 8, is still fairly high and higher than the significance level. So that's saying that we are going to accept H0 and no evidence to support the Director of Studies claim, because he thought it was greater than 30, but there's no evidence to support that. Okay, part C. The teachers believe that the sample originally in the survey was biased, and they claim that only 25% of the parents are in support of the new curriculum. A second sample of size 2n is taken, exactly half. So now instead of it being 20, it's now 2n, and instead of in this case being 8, it's going to be half of that sample size. So we're carrying out a test at the 10% level, and we need to see whether the teacher's claim is being supported. So it's telling us what to use as our hypotheses. So X is binomially distributed with sample size 2n and 0.25, because our null hypothesis is that P is equal to 0.25. Our alternative hypothesis is that P is greater than 0.25. So we're looking and trying to find the minimum value of this n, so that when we do the probability of X being greater or equal to that n, it's going to be less than 0.1, which is the significance level, the 10%. So find the minimum value of n for which the outcome of the test is going to reject the teacher's belief, and the teacher believe that 25%. So we want to be rejecting the null hypothesis in favor for the alternative hypothesis. Therefore, this probability has to be below the significance level. So what you need to do is just go on your calculators and find a value. So we can say maybe X is binomial distributed. Start with a low value here for the double n, because we're trying to find a minimum. So let's try that 2n is 8 0.25, then what would be the probability of x being bigger or equal to half of 8, which is 4? And if you do that on your calculator, that comes out to be 0.1138, which is 11.38. So that's too big because that would not be in the critical region. We need this to be less than 0.1. So now try x binomial distributed. Now we need to have an even number here so that when we half it we get a whole number here. So the next one would be 10 and 0.25, and then we'd be looking at probability of x being bigger or equal to 5, half of the 10, and that comes out to be 0.0781, which is below the significance level. So we found the minimum value, and the actual value of n is this number here. N is equal to 5. Now going on to the mechanics question. Question 10, we've got P and Q being dropped from the same height h above a horizontal ground. P is dropped from rest, but half a second later Q is thrown down with speed of 7.35. They hit at the same time. We've got to find the value of h. So we've got them traveling a distance of h, P and Q. P is dropped from rest, so its initial velocity is 0. Q is thrown down, its initial speed is 7.35. So we need to set up our S.U.V.A.Ts because it's constant acceleration. Both are falling due to gravity. So for both of them, the acceleration is going to be 9.8. The distance we're trying to find is h is for the same. For P, the initial velocity will be 0. We don't know what the final velocity, and we're just going to call the time t. For Q, if we do the same set of equations, so S is h, they're both traveling the same distance. 7.35 is the initial velocity. We don't know the final velocity. It's 9.8. And then in relation to this t, Q is going to be traveling half a second less, so that's going to be t minus 0.5. Now the S.U.V.A.T equation we're going to be using is S is equal to ut plus half a t squared. So for P, that's just going to be that h is equal to 0 plus half 9.8, which is 4.9 t squared. For Q, S or h will equal ut. Now because there was some u, that's going to be 7.35, and the t is going to be t minus 0.5 plus the half 9.8, so 4.9, the t minus 0.5 squared. Now these h's for both are the same, they travel the same amount of distance, so we can equate these sides to each other. So 4.9 t squared is equal to, multiplying this in, it's 7.35 t minus half of 7.35, which is 3.675, plus 4.9, and then squaring this out, it's going to be t squared minus t plus 0.25. Then if we multiply this in, we're going to get 4.9 t squared is equal to 7.35 t minus 3.675 plus 4.9 t squared minus 4.9 t, and then plus 4.9 times 0.25 is 1.225. Now what we can do is take 4.9 t squared off both sides, and then take all the numbers to one side and collect the t's together. So this minus 3.65 and the 1.25 over to the other side comes out to be 2.45, and then the t terms, 7.35 minus 4.9 is also going to give us 2.45 t. So that's telling us that t is equal to 1. So P takes 1 second to fall. So back into the t equation, when t is equal to 1, h is equal to 4.9 times 1 squared, which is 1. So h is equal to 4.9 meters. This last question is on pulleys. We've got this system here. It's released from rest, and B is going to travel the 1 meter and hit the floor. So while it's traveling, the string's going to be taut, and we're going to have the forces. What force is going to take it down? It's 2 mg. There's tension pulling it back because we've got A the other end. We've got a driving force here, T, and there's a frictional force on the table, so that's going in the opposite direction to the motion. Now we can apply F equals ma to both A and B. So for A, it's going to be T minus F is equal to 3 ma. For B, it's going to be 2 mg minus T is equal to 2 ma. Now we've got T, F, and A, 3 unknowns, and we're not going to be able to solve it with those 2 equations. And for part A, we're being asked to find the acceleration for the first 2 seconds. So for part A, you've got to do some S.U.V.A.Ts just on B, because we know it's going to travel 1 meter in the 2 seconds. Its acceleration we don't know. It's released from rest. So we're going to use S is equal to ut plus half at squared. 1 is equal to 0 plus half a times 2 squared, which is 4. So half 4 is 2. 1 is equal to 2a. So a is equal to a half, or 0.5, and that would be meters per second squared. In part B, we're asked to find the magnitude of the friction. So now that we know that the acceleration is a half, we can put that back into these 2 equations and see where we are now. So we've got in the first equation for A, we've got T minus F is equal to, if A is a half, that's going to be 3 over 2 m. For B, we're going to have 2 mg minus T is equal to, well, if A is a half, times it by 2, that's just going to be m. So what we can do with this equation is rearrange it to give us T. So 2 mg minus m is equal to T, and substitute that in up here, and then rearrange for F. So T, which is going to be 2 mg minus m minus F is equal to 3 over 2 m. Now G is just 9.8. Doubling that is 19.6 m minus a whole m. Take this m to the side, which is minus 3 over 2 m is equal to F. And then if you saw how many m this all is on the left, it's going to be F is equal to 17.1 m. Final part, part C, will A reach the pulley? Because what's going to happen is the system is going to go until B hits the floor, which means A will travel 1 meter towards the pulley. Then the string will go slack, so there'll be no driving force. The tension won't be there anymore. There'll still be frictional force slowing it down. So will that friction force be enough to slow it down so that it comes to rest before it hits the pulley? And it's just got to travel 0.3 left. So what we need to do is find the final velocity once the system is released from rest, when the string is still taut, because that will be the initial velocity when the situation changes, when the string goes slack. So let's do some S.U.V.A.Ts first. We're going to travel 1 meter. The initial velocity is 0. We're trying to find V. Our A is 0.5 that we've already found, and we're traveling for 2 seconds. So we've got a choice of S.U.V.A.Ts. I'll use V is equal to U plus AT. So V is equal to 0.5 times 2, which is going to be 1 meter per second. So that's the final velocity when V hits the floor, the string goes slack. Well, that will be the initial velocity at this situation when A has travelled 1 metre. Now, when it's travelled 1 metre, the force equation will change because there'll be no driving force anymore. So applying F equals ma to this new situation when the string is slack will allow us to find the new acceleration. So the only force in the line of motion is the minus 17.1 m, which is the friction, which is equal to 3 ma. So the m's will cancel, and our new a is going to be minus 5.7. So when the string goes slack, we can try do our new S.U.V.A.Ts. We want to know what distance will it reach before it comes to rest. It's going to have initial velocity 1, which was the final velocity here. We want the final velocity to be 0 because we want it to come to rest, and the acceleration is going to be minus 5.7. So the S.U.V.A.T equation we need to use is v squared is u squared plus 2as. So 0 is equal to 1 plus 2 times minus 5.7 s. We take that to the other side, so 2 times minus 5.7 is 11.4. Take to the other side will be plus 11.4. S is equal to 1. S is equal to 1 divided by 11.4, which comes out to be 0.0877. So the thing's going to travel another 0.877 meters and then stop. So this is going to be less than the 0.3, so it will stop before it reaches the pulley, and A will not reach the pulley. Thank you so much for watching. Hopefully you found the content of this video useful and helpful. If you are about to start year 13 maths, best of luck. Hope all goes well for year 13 for your maths A level. Do like and subscribe. Keep an eye on the channel because there's more help on there as you progress through year 13, and I will hopefully see you on the next one.